Hello everyone and welcome back. My name is Mr. Kovalt, and in this video I'm going to be going over percent yield with an example problem. So let's get into this. So when you're thinking about percent yield is a relationship between the amount that you theoretically should get from the reaction if it was to react 100% efficiently and you're not going to lose any product or anything like that versus what you actually get in the lab. So the calculated amount based upon stoichiometry versus what you actually get when you perform the experiment in the lab. So that's the what percent yield is. And so up here I have the equation that percent yield is going to be the actual yield. The actual yield is the yield you actually get in the lab. This is reality. This is what you really get in the lab versus the theoretical yield, right? So actual yield divided by theoretical yield, which is the calculated value that you would get in theory based upon your stoichiometry calculations. And then multiply that by 100 to get the percent. So it's a fraction of the actual yield over the theoretical yield multiplied by 100. So that's how you calculate the percent yield. So in a percent yield problem, they have to give you the actual yield in the problem. You're not going to go into the lab during the homework problem or the test or whatever it is, right? They got to give you the actual yield in the problem itself, right? So that's going to be given to you. They might give you the theoretical yield, but most of the time, the theoretical yield is something you have to calculate using stoichiometry. So once you calculate the theoretical yield, you then plug the actual and theoretical yield into the formula, and you get the actual the percent yield. So let's go ahead and do this problem as an example. So in this problem, here we're given the reaction. So here we have 3 moles of 2-methyl 1-propanol reacting with PBr3 to form 1-bromo-2-methyl propane plus some H3PO3, which is phosphorus acid. Okay, so here we're given the situation. In a student experiment, 5.3 93 grams of 1-bromo-2-methyl propane forms when an excess of PBr3 reacts with 6.034 grams of 2-methyl 1-propanol. What is the percent yield? Now, one thing that I want to point out right away is this phrase here, when an excess of PBr3 reacts. So you're told right off the bat that you have an excess of PBr3 reacting with a given amount of the other reactant. So because we're told we have an excess amount of one reactant, that means that this is not a limiting reagent problem because they're already telling us what the limiting reagent is. It's the 6.034 grams of the 2-methyl 1 propanol. Why? Because the PBr3, they already said that's an excess. So, and they don't give us an amount of it. So the only amount we have to deal with is this one. This is the limiting reagent. We don't have to figure out what the limiting reagent is. That's it. So what we need to do is figure out what's the theoretical amount of the product that would come from this amount of the 2-methyl 1-propanol. So we start with the 6.034 grams of the, and I'm just going to say propanol to make it clear because we have propanol and we have propane, so 2 different substances. So I'm just going to say propanol. So we have this many grams of the propanol, and so we need to convert this many grams of propanol to the product, which is the propane. So we're given mass. We need to convert from one substance to the other. So we need to get to moles so we can use the mole ratio to convert from propanol to propane. So we need the molar mass to convert grams to moles. So the molar mass of the propanol is 74.123. So we have 74.123 grams of the propanol. And that's going to be 1 mole of the propanol on top. So grams of the propanol cancels out. We have moles of propanol. Now I can use the mole ratio between the propanol and the propane to convert to the propane. So here, so if I look at this ratio, is I have 3 of the propanol and 3 of the propane. So it's 3 to 3. So 3 moles of propanol on the bottom and 3 moles of the propane on the top. So the moles of propanol cancel out. So now I have moles of propanol. So now I can convert to grams using the molar mass of propane. So the molar mass of the propane, give me a second. That's going to be 137.01. So 1 mole of the propane on top. And again, that's going to be the 1-bromo-2-methylpropane. I'm just shortening the name. And that's going to be 137.01 grams of this propane. And so moles of the propane cancel out. That's going to be giving me grams of propane. So all I need to do now is multiply by everything on top, divide by everything on the bottom, and I get my answer. And the answer is 11.15. So that's going to be equal to 11.15 grams of the propane. So this is what I should theoretically get from the lab based on like the laws of chemistry and physics, and if everything was perfectly efficient, I should get 11.15 grams of this propane, right? So this is the theoretical this is what we should get in theory, but according to the experiment, there was only 5.393 grams produced during the experiment. So this is the actual yield, this is the theoretical yield. So to find the percent yield, so percent yield is going to be equal to the actual yield, which is the 5.393 grams, divided by the theoretical yield, which is 11.15 grams, and we're going to multiply that by 100, and we get 48.37. 48.37%. So that is the percent yield based on the calculations that we have. So only 48.37% of the theoretical yield was actually yielded by the experiment in the lab. Okay, so that's the percent yield. And again, for the number of significant figures, remember, since we're multiplying and dividing, the number of sig figs in your answer should be equal to the number of sig figs, the least number of sig figs in your measurements. So since we have 4 here and we have 4 here, therefore we have 4 here. So that is how you find the percent yield. I hope this was helpful. If you enjoyed this video, if this helped in any way, then please, by all means, like the video, hit that like button, share the video with your friends, subscribe to my channel. When you do, make sure you click click that notification bell. And when you do, click all, so that way you can be notified by all the videos I put out. And then finally, put a comment down below in the comment section, please. Let me know what you think. Ask me questions. I would love to hear from you. If you have a problem you want me to help you solve, or a question you want me to help you answer, or if you have a topic you want me to cover, I would love to do that for you. Thanks for joining me, and have a great day.